Here in this circle D, we are to solve the values for the variables x, y, and z. But it's important to also consider the given situation where the W is a point of tangent C. That would mean this line here, as it passes through point W, this is tangent to circle D. In order for us to solve the unknown variables, aside from the given that point W is a point of tangent C, which ultimately tells us that this is a tangent line, we also need to understand what are the representations of x, y, and z. For x, this is an angle formed outside circle D from a secant segment and a tangent line, or a tangent segment until here, or tangent line if this is to be written forward. So this is an angle formed outside, again by a secant and a tangent segment. Y is a tangent formed by the same tangent segment and a chord here. And Z is also an angle formed by that given tangent segment and the same chord that makes the angle Y. So let's start with solving the value of the measurement for angle X. Angle X again is an angle that is formed by this secant segment and this tangent segment. It has actually a unique perspective on its measurement if given like this. An angle formed by a secant segment and a tangent segment outside the circle, its measurement is actually equal to 1/2 the positive difference of the intercepted arcs of the given angle. That would mean the difference between the first intercepted arc, which is this, which measures 80 degrees, and the second intercepted arc from this point to that point, which measures 124 degrees. It is good to note that other references, instead of saying positive difference, they are using absolute value, because there might be situations where we are to interchange the values for the intercepted arcs. We may start with 80 before 124, and therefore by difference we get negative result. And since we do not have any negative measurement for this angle, other references call it as absolute value of the difference. But just for this case, let us use the larger value first minus the smaller value of 80 degrees. So this is an equation that will be used to solve the measurement of angle X. And that would mean 1/2 of the difference, which is 44 degrees. In short, the measurement of angle X is half of 44, that's 22 degrees. This is the angle or the measurement of angle X as it follows the theorem which involves an angle formed outside the circle from a tangent and a secant segment. For angle Y here, okay, this angle is not an inscribed angle. This angle is an angle formed by the tangent segment and the chord here. Okay. But even if it's not called an inscribed angle, there is a specific theorem that tells us about angles formed by a tangent segment and a chord. It follows the same computation as the inscribed angle, though it's not inscribed. It would mean that the measurement of angle Y here is just simply half of the measurement of its intercepted arc, which is actually 124 degrees. This would mean that the measurement of angle Y is just simply 62 degrees. That's for angle Y. We are done with angle X. Let's move to the last unknown measurement. That's the measurement of angle Z. Now we can attack this in two different ways. Number one is by simply looking into the perspective about the relationship of the angle y and angle z, as they are adjacent angles that are formed by the same tangent segment in the same chord. They are actually forming a linear pair. Okay. When you say linear pair, the measurement of both angles, when added, measurement of angle z plus the measurement of angle y, is simply 180 degrees. For if it say about angles forming a linear pair, they are supplementary. And since we already have the value for y, which is 62, we could just simply substitute here the measurement of angle z plus the solved value for y, which is 62, must be equal to 180 degrees. That would mean the measurement of angle z is the difference of 180 and 62, which will give you a result of 118 degrees. This is just one way of attacking or in solving angle z. But of course, you could also use the same concept that you used earlier in solving angle y, for it is an angle that is formed by the chord in a tangent segment, and it's simply having the same concept as inscribed angle, half of the measurement of its intercepted arc. But the intercepted arc of angle z is not complete, for it only has this measurement of 80 degrees, but we don't know the measurement of the remaining. But since it's a complete circle and it's the remaining arc, we could solve for this. Let's say this is w. For this to become a circle, the measurement of w plus an 80 degrees measurement plus 124 degree measurement must be equal to the entire circumference of 360, that's 60 degrees. So in solving that, we'll have w is equal to 360 degrees less the sum of the two given arcs, which is 204 degrees, which will give you a result for w equal to 154 degrees. That's just for w here. Again, this is just one way to attack the problem in solving z, because once we know w to be 154, we know that this should be half of the intercepted arc. So the measurement of angle z must be equal to 1/2 the measurement of its intercepted arc, which is given already as 80 degrees, plus w, which is 154 degrees earlier. Okay, pardon, there is something wrong here. Let me erase this first. It's not 154. It is actually 156. So this should also be 156. Okay. So if we are to continue using the concept of an angle formed by a tangent and a chord, you will have this half of 236 degrees. And half of 236 degrees is 118 degrees. Look into the values solved earlier using linear pair postulate, and this using an angle formed by a tangent and a chord, and its measurement is half of its intercepted arc. They are just the same. So this is how we solve the unknown measurements for the given circle D.